Okay, now let's review what we did in this particular video. We wanted to sketch the graph of the function f of x equals to x to the power of 1 over 3 times x minus 4 to the power of 2 over 3. We found the first derivative, understood how to simplify the expression to find the critical numbers. So this first derivative was 0 for 4 over 3 and does not exist for x equals to 0 and 4. Analyzing, we found that it is increasing in the interval from minus infinity to 4 over 3, decreasing in the interval 4 over 3 to 4, and thereafter increasing. We had a maximum at 4 over 3, a minimum at 0. So this is what we learned in the first part, right? So, and then we analyzed the second derivative. I prefer to use the method of logarithms to find the second derivative, and then we found the second derivative as minus 32 over this expression, and then we analyzed that the critical points for us was at x equals to 0, x equals to 4, and at these 2 points we had a point of inflection at 0 where the concavity changes from positive to negative, right? So we have a point of inflection at 0. I tried to sketch this here, but there was very less space. So now we are moving on to the third page. For the first time I'm doing that. Moving on to the third page. In this third page, I'm going to summarize all what we have learned and then finally sketch the graph. Okay, so let me write on the expressions which we have got so far. This first derivative for this function was, let me copy this from, okay, so the first derivative from the first part was 3x minus 4 divided by 3 times x to the power of 2 over 3 times x minus 4 to the power of 1 over 3. The second derivative which we found was equal to minus 32 divided by 9x to the power of 5 over 3 times x minus 4 to the power of 4 over 3, right? So this is all what we did about the derivatives. We also learned that the domain is all real numbers, right? So we have domain x belongs to real numbers, so it is continuous graph actually, and we learned that increasing interval is from minus infinity to 4 over 3, and then from 4 to infinity, correct? You can go back to the video and see these things. Decreasing interval was from 4 over 3 to 4, okay? And we also found that the maximum and minimum points we found, right? So we had maximum at 4 over 3, approximate value is 2.1, and the minimum was at 4, value was 0, okay, 4 and 0, and we found point of inflection at 0, right? So we found point of inflection at 0, right? Okay. So at 0 the value is 0, so point of inflection at origin. Okay, that's great. So this is what we found, and as far as concavity goes, concavity we found concave up. Let me write down, okay, concave up in the interval from minus infinity to 0, right? And then concave down from 0 to 4, and then from 4 to infinity, right? So this is all our learnings from the previous part of the video, and now we are going to sketch the function based on all this, correct? So we'll just sketch the function based on all this. So let me make a rough sketch of the same. Now I have more space to work with, so okay, so most of the values are on the right side of the origin, so I'll keep more space there when we sketch. That's fine. Critical points which we are looking into are the x-axis, on the x-axis and the y-axis, that is the origin. The critical points which we are looking are at 0, and then we have 4 over 3, which is 1 point something. So let's say somewhere here is 4 over 3 for us, and then at 4, right? So somewhere here we'll keep 4 for us, right? Now, the graph, let me summarize our learnings here once again, looking into all this. The nature of the graph, concave up from minus infinity to 0. It's kind of like this in this interval, and concave down is kind of like this in this interval. Do you see that? That's the shape of the graph. Perfect. And we have a point of inflection at 0. Point of inflection at 0. It's kind of like this. So what we can do, that in this part, we can sketch the graph as like this. This is like concave up. Okay, end behavior we could talk about also. End behavior, which we did not talk about earlier, is when x approaches negative infinity, then you will notice that y approaches, if x is very, very large, negative infinity, so in that case y approaches negative infinity, and if x approaches positive infinity, y approaches what value? So y also approaches positive infinity, right? So the end behavior is kind of like this. Do you see that? So it's like approaching towards the negative infinity. Is it okay? Right. So that is end behavior. It's good we added something in this part also. Now, we have a point of inflection here and a maximum somewhere there at 4 over 3. So maximum at 4 over 3 is, let's say, some point here. So what we have to do is we have to change the concavity and then turn from here, right? So we change the concavity and turn. So that turn happens to be at 4 over 3, a smooth turn. Change of concavity signifies that this point is point of inflection. I hope that is clear, right? So we have taken care of this point of inflection. Now when you turn, you have to go concave down, and then at 4 again this concave down. But at 4, what we observe here is that we have minimum. So we have already taken care of this maximum, which is at 4 over 3, approximately 2.1. So we've taken this as the maximum. Now for the minimum, it is at 0. We also learned that the derivative here at 4 is not defined. So that means we are expecting a vertical kind of a tangent line, right? So this happens to also be a cusp. To show that, what we have to do here is that we have to just turn back kind of like this and then go like this. Do you see that part? So this ensures a cusp here, and also ensures that the concavity is decreasing as we had decided. Do you see that? Now to make a graph very smooth, you could take some more points and make a good graph on your graph paper. But I hope with this you learn all the things, rather review all the things which you have learned in calculus up to this part, talking about derivatives, right? So half of the calculus we have covered in this video. So I hope it was worth spending 15-20 minutes, I don't know how much. So whenever you find time, you can always continue with this video and understand. Thank you for your patience. You can always share, subscribe my videos, and post questions. Put some likes if you want. Thank you, and all the best.